Hi, this is a presentation of the routing table, and it's a part of my CCNA2 course. The routing table and the entries of the routing table can either come from our static routes or from the dynamic routing protocols that we set up. Of course, it will also be populated automatically with our directly connected interfaces. So if I do a show IP route, I will see the content of my routing table. And then I will see here that the first I see that is I have a default static route, and then I can see I have some routes that are directly connected with a C in front of them. I can see that I have an L in front of some of them, which is the IP address of my local interface. I can see that I have some RIP routes because I have an R in front of the entries. Yeah, and that's basically it. So if we try to look at it, if we start with the directly connected entries, is the one my own directly connected networks, or the router's own directly connected networks. The C indicates the network address that's directly connected, and the L indicates the IP address, the specific IP address of our interface. In this case here, it's our G00 interface. And we can also see that the L has a /32 subnet mask, which means that this is a host address, not a network address. Yeah. If we look at the remote network entries, for instance, something I've learned from the RIP protocol, we can see that the R in front of them will tell us that this is a RIP route. Then the destination network, then the administrative distance, which is the trustworthiness of the routing protocol. RIP is not very trustworthy, so we have a high administrative distance. Then we have the metric. In RIP, it's the hop count. How many routers do I need to hop through to get there? And then we have the next hop, and we have the timestamp, and we have the outgoing interface. So these are the entries for something that we have learned from our dynamic routing protocols. When we are looking at the routing table, we have different types of routes that we discuss. We have something called a ultimate route, and then we have level 1 routes. And the level 1 route could be is a parent route, and then we have a level 2 child route. This is something we have if we do subnetting. If we do not do any subnetting, then we have ultimate routes. So let's look at some example. The ultimate route is a route that always has an exit interface or a next hop IP address. This is, for instance, all our directly connected routes are ultimate routes, and the ones that we learned from our dynamic routing protocols are also ultimate routes. So in this example here, we have the static route first, and then we have the routes with the C, L, and R in front of them. They are all ultimate routes. A level 1 route is something when we have, could be, for instance, if it's an ultimate route, well then it's either just a network, normal network, which is not subnetted. We could have a supernetted, as something that's summarized, and we can have a default network that is a ultimate level 1 route. Then we have something called a level 1 parent route. And this can be described as some sort of a headline, something that we set up or we can see in our routing table if we have done some subnetting. For instance, here we have the 172.16.00/16 is a variably subnetted into 5 different subnets with 3 different masks. So this is just the headline. This has no exit interface, it has no next hop, so we cannot send something to this line. So this is, for these 2 networks, in this case here, we can see that this is just, to tell us that we have done some subnetting with these 2 network addresses. So a level 1 parent route is just something that tells us that there is a subnet going on. Then the child root, the level 2 child root is of course the child for the parent, which means that this tells us how we have done the subnetting. So this will tell us, if I have the parent route tell me that I have 5 different subnets, well then I have 5 different child roots, which will tell us exactly which subnets do I have on which interface, or with which next hop route. So it will tell me how this subnet is actually done. And you can see here that the child root also have an exit interface or a next hop route. So what happens when I get something in is that I try to find out, when I have an IP address, I get a packet with an IP address on. I look at the network part of that IP address, and then I start looking into my routing table. So if I have a match on my level 1 ultimate route, well then this is used. If I don't, well then it will try to find out with a parent route, because then it will look at, is this IP address subnetted in anyhow? And if I have, then it will go to the child route and then try to find the best match with my subnetted routes. If there is a match, well then it of course will send it out on this interface. If there is not a match, well then it will go to the next step, which is to try to find out whether there is a summarized route that has a match on this one. If not, it will go and look at, is there a default route? Because basically a default route will almost always match. And if there is no match at all, then it in the end will drop the packet. So the best route is the longest match. So if I have an IP address 172.16.0.10, then it will look at my different routes in my routing protocol table and find out what is the longest match for this destination, and it will choose the one with the longest match with most corresponding bit. Yeah. When we look at it in an IP version 6 perspective, the things have actually become a little easier because we don't really subnet. So all IP version 6 entries are ultimate routes. So we don't have any level 1 parent or level 2 child routes in IP version 6. Yeah. So example here of an IP version 6 routing entry, well then we will just see here again, if I have a C in front of it, it's a directly connected network. Still we will see the AD and we will see the metric and the outgoing interface. On a, for instance here, an EIGRP route, well then again we will see where it's come from, we will see the destination network, we will see the AD, which in this case is 90, we will see the metric and the next hop and the outgoing interface. Yeah, and that was it. Thank you.